Welcome to Security Architecture Podcast, where we help cybersecurity professionals to stay ahead of the curve and ensure they are successful in their cybersecurity journey.
Hi, I'm Evgeny.
I'm Dimitri.
We have here Gil from Axis Security. Gil, can you please introduce yourself and tell us more about the company?
Sure. Thank you, Evgeny. My name is Gil Azrielant. I'm a co-founder and CTO at Axis Security. Axis Security is a company that makes secure remote access amazingly simple, and we provide remote access and zero trust access for large enterprises around the world.
Gil, tell us please, what's the name of the offering or the product that's addressing the ZTNA remote access?
So our product's name is the Application Access Cloud, and it's intended to imply that we do not give network access ever, no matter what. So the zero trust network access, even though we're part of that category, we never actually give network access to anyone because focusing on giving access on the application level is something we find to be more secure and more correct.
We are a podcast about architecture. So we really would like to learn about your architecture, how you guys designed native cloud, private cloud, AWS, GCP, Azure, why you build it in a way. If you can share your architecture in a slide, whiteboard, in any other way, it's really, really interesting for us, and how you route the traffic, how you decide where the traffic is going.
And let me show you in very broad terms how the deployment looks like. So on one hand, you have your applications and your servers and services, and they could be anywhere in the world. This means in many public clouds, different VPCs, on-prem, data centers, co-locations. It doesn't really matter. And your apps are all over the place, but your users, and especially since COVID, your users are all over the place as well. So they're gonna come from anywhere in the world using any device. Now, architecturally speaking, what happens is that this connector right here, which is the green rectangle you're going to see inside your network, that's the only thing we ever put on your network. And it connects back outbound only, TCP and UDP, into the Application Access Cloud. It mutually authenticates using a one-time certificate, and it forms this secure connection on the application level. It's never a tunnel, and the cloud never enters the network. Once this secure connection is configured, is up and running, the user is going to use the Application Access Cloud as the front end of the application. And here we divide our offering into the agent-based offering and the agentless offering. For the agentless offering, we're going to use all the points of presence all around the world of the major cloud providers. We're going to use all sorts of anycasts and techniques that are intended to really lower the latency on the second, third, and fourth layer. So the user could be in Paris and they're going to go to a server in Paris on their way using the tier 1 network of the cloud provider. At the cloud, what's going to happen is context is going to be added to the request, meaning who the user is, what their permissions are, who the device is, what's the posture and what's the trust put in it, time of day, history, all of those different context variables taken into consideration before getting the policy verdict in the cloud. Now, only granted that the specific request is allowed in this specific context, the cloud is going to facilitate the request through the connector into the application and back. It's very important to note that before getting a verdict from the policy engine, nothing ever happens on the end network. So the security and the demilitarization of all the traffic, the authorization, everything happens in a way that's completely external to the network and the application. This sort of way to be sort of a very smart reverse proxy does not require any changes to the applications or the servers or the networks, but it also does not require any change to the user endpoint because we do leverage the capabilities that are already in the endpoints for that. The agent-based offering is a bit different because it requires you to install something on the endpoint, but then it allows any kind of traffic, and I mean any kind because many people say any kind but mean only some kinds. to be used there. This is very good for native applications, for hard-coded IPs, for VoIP and peer-to-peer communication, which is something we uniquely do in the space. And it's also good for server-initiated flows, things like pushing updates from the application to the endpoint and not going the other way around. These become possible all of a sudden. Another way of looking at it is not that we have two offerings, but we have two complementary offerings. You're gonna get anywhere between 80 and 95% of all use cases done right away without having to roll out agents, without needing to make change to the endpoints. And then for these harder, trickier use cases like your call center, your server-initiated flows, and your peer-to-peer communication, for those, you're going to install the agent for the remaining 15 to 5%. So the offerings complement each other and really give comprehensive end-to-end remote access solution.
Can you elaborate a little bit more about this one-time certificate that you mentioned in the beginning and the unidirectional communication?
Yeah, of course. So in many cases, and you're going to see this in the older solutions that do zero trust and the pioneers, you're going to have to put something on the internet in your DMZ, or maybe punch a hole through your firewall so that the cloud will be able to reach the connector. This is problematic for many reasons. First of all, this machine has a target on its back. People will try to compromise it because they will realize that this is the entry point to the organization. You see this very often when you find vulnerabilities in VPN concentrators. Because this is the low-hanging fruit, because by definition it's on the internet, people try to target it. Now, our connector, you're going to get the deployment script and the one-time certificate from the management console, and then you're going to run the command on a VM in your network. The communication is going to be outbound only. The firewall rule will only have to allow outbound traffic, never giving a public-facing IP address to the connector. Before doing anything, you have to make sure that no one's trying to impersonate as the connector and try to steal traffic, which is an attack we've seen in the past for other companies. The ability to have this one-time certificate in the VM prior to doing anything really allows the cloud to make sure that the right person or the right actor is trying to spin up a connector, and not someone who stole a certificate from a machine somewhere in the network, for instance.
So that's a certificate that you would install once you're deploying the connector, and it's gonna stay there. How often you need to change it, or does it change automatically for every connection, or maybe every number of hours or days?
So that's a great question, and we have seen all sorts of demands there. Some organizations, especially MSSPs, they want to use automation to spin up and spin down connectors. So for them, they can configure it to be a daily thing, for instance. Other companies would rather have it be a longer lived connector and have it stay for months or even years. So it's really up to the policy of the customer or the user, because they are the ones who need to specify how often they want to replace the connectors.
Can you run the connector in a container?
Yes, the connector actually is containerized. So if you have Kubernetes, if you have a Docker service, or if you have Docker installed within the VM, in either one of those cases, the connector can run. And we've seen many enterprise customers that want to really containerize whatever's running on the machine for hygiene and for easier maintenance. Another thing worth noting here is that our cloud leverages, that's a multi-cloud environment. So we have redundancy across different availability zones, but also across different cloud providers. So even if something happens and AWS is down for the entire day, we have backups on different cloud providers. So the redundancy and the high availability is really top of mind when we designed this system. It also helps accelerate the traffic, because instead of the old model where you go to a VPN concentrator somewhere in the world and from there you go wherever you're going, and this could mean a very long round trip between the user and the app. Here, both the connector and the user connect to the closest point of presence to them. And then most of the traffic goes through the fast tier 1 network of the different cloud providers. And when you add global accelerator to it, any cast IPs that really minimize the numbers of hops you need to go, and techniques of that nature, you really get acceleration in most cases rather than bad impact on the.
Another question that comes to my mind now when you mentioned it is you touched a little bit around opening outbound permissions to connect to the Axis Cloud. Now, Axis Cloud, from my understanding, can spread around Azure, GCP, and AWS. Do you have static public addresses there for your service, or it's more like dynamic addresses and you need to use FQDNs to open these permissions on the firewall side?
So we do have a narrow list of static IPs that can be used, and during the more strict configuration, you can limit the use just for that. We also have FQDNs that denote all of our IP addresses. Working with enterprise customers, you're going to find that the number of demands and the number of unique demands are infinite. Our willingness and our openness to adapt to the different demands of each enterprise customer, those really led us to be in the situation where for many questions that you're going to ask, I'm going to say this, but also this and also that, because different organizations have different demands.
Did you had any requests of customers, maybe big enterprise companies, to give them a separate infrastructure just for their company?
Yes, we did get that. And, this request comes with a very high price tag because the multi-tenancy is a huge advantage, but also the ability to maintain things separately. The largest of the large, the US Department of Defense and some of the largest companies in the world, they can and they do afford it. Generally speaking, Fortune 500 companies are happy to use the multi-tenant environment that we have. But that request definitely came up more than once.
Can you elaborate a bit more? So you mentioned you use the AWS GCP Azure backbone. So if I want to go to Australia from Toronto, I'm going to hit the AWS or Azure GCP in Toronto, and then the traffic will be routed inside the AWS infrastructure backbone and get out in Australia AWS, or I'm missing something?
No, that's exactly right. In some rare cases, you're going to find crosses that you're going to enter in AWS but leave on GCP, for instance. But these are really the edge cases. I think Toronto and Australia are two pretty common countries. If you chose more, yeah.
Why you decided to use this architecture and not just take me all the way to Australia, or just use the enforcement in Toronto and let me go on the internet?
For a couple of reasons. One, it's very important. Speed and latency and user experience are very important. And if we could improve dramatically the experience of, we have a customer that has offices in Bangkok and London and New York and San Francisco. So if we can improve their global operation, we can improve their user experience dramatically, then that's a huge selling point for us. So our ability to accelerate traffic and use techniques that are used in CDNs and, using any cast IPs and the global point of presence network and edge computing, if we can leverage all that and give a 20% boost in performance, this wins bake-offs and this delights our customers. And our ability to do that is really instrumental in the company's success. So using the public internet is not our first choice. And since we already enforce the policy within the cloud, there is no point in leaving the cloud before the last possible moment. You want to stay on the highway for as long as you can and then go through side streets for as little as you can, if that makes sense.
How do you license your product?
So people will find that we have a very open mind around licensing. I will tell you that in practically all of our accounts, it's either licensed by seats or by concurrent users. Seats because that's how people are used to think about SaaS solutions, and concurrent connections because that's how people are used to think about VPNs, essentially. So these are the two more common ones. If, for instance, we have a chip manufacturer that uses, that does machine-to-machine traffic, and there's lots of bandwidth. And for that specific instance, we both realized that it would make no sense charging per user because it's mostly machine-to-machine, so the users are not significant. So we found a way to charge around bandwidth for that specific instance. So we're not very strict about that.
Let me ask you a question then in regards to the seats. So let's say I have my laptop and I have my mobile phone. Would I need 2 licenses or just 1 license?
So we currently don't charge by devices at all. The company started thinking that work from home and work from anywhere and the ability to bring your own device, they're very crucial when you want to have a global operation. So we take into consideration the fact that people have multiple devices and we don't charge by device.
Can you elaborate a bit more? How do you tie to MFA and single sign-on?
Okay, so we have a very flexible way to connect to your MFA or single sign-on. So practically all identity providers will give you SAML, OAuth, and LDAP integration so that we can consume the identity that you invested in. Now, in some organizations, you're going to find that they have many subsidiaries and many different organizations that have different identity providers. So we allow you to really integrate all of those identity providers into our platform and have a cross IDP policy for all. In some cases, it does not make perfect sense to give an Okta user to a contractor or a person who's very temporarily needing access. For these cases and others, we give the Axis identity provider as well. So you can have your Okta, your Ping, your Active Directory, one of your subsidiaries, SailPoint, but then also use the Axis identity provider for those use cases where the user needs to be added temporarily for POC purposes, etc. So using all of those integration types, we bring all the identities together. Our policy engine queries and checks these identities against the policy. MFA can be triggered either by our platform. We support MFA natively, or we can consume your MFA if your Active Directory is connected to your Duo or your Okta has MFA. So all of these models are possible. And it takes me back to when you have many enterprise customers, you're going to get all the different demands and led us to really support all of those use cases apart or combined.
Let's say I'm a company with 5,000 employees. How would you recommend me to go ahead and integrate or onboard your solution to my users?
Our solution, we will support clientlessly almost every use case that is common. So the way I would suggest doing it would be A, spin up a connector. It takes 5 minutes. B, integrate with your Okta, with your Active Directory, with your identity provider. C, set up some simple policies around the most important applications of the organizations. And D, show what applications they are. When you do this, you're going to have, and this can take under 30 minutes to give full access to a few dozens of applications within the organization, again, without rolling out anything to the endpoint, without changing the applications or the network. After doing this, you're going to get much relief because many users will be able to stop using the VPN, maybe even have their credentials revoked. Now, as to the rest of the users, those who have to use the clients, the call centers, those who have to stream video or use peer-to-peer communications, for those, I would recommend that you later roll out the agent, have it be installed, and define policies around those use cases. Then you're going to have the full network or the full access.
How would you roll out the agent? Like, would you make some rule in your group policy that will push it to the remote computers? Once they connected over VPN, would you send email with link to download the agent and instructions? How usually your customers are doing that?
So most enterprise customers will just use their MDM to push it to all the clients without any hassle. In some cases, they would rather have it be self-served. So the user would go to the portal, download the client and install it. This is more common where bring your own device or unmanaged devices come into play. But these would be the two main ways of rolling out the agent.
You mentioned about the client, and I'm wondering, you also mentioned about VoIP. Can you elaborate how VoIP working? Because we understand it's not so straightforward for many, many vendors.
So VoIP has many different protocols because essentially, in most cases, you're going to have two people that want to communicate with each other directly, but they're both going to be behind a NAT. So there are all sorts of protocols like STUN and ICE and SIP. All of these protocols that are intended to form a peer-to-peer communication over a network where both users may be behind a proxy or behind a NAT. And B, it does not start as a client-initiated thing to the server, but rather a peer-to-peer communication. This is a very hard problem. And if you're gonna shop around for ZTNA solutions, you're gonna find that none of them supports VoIP perfectly out of the box. I'm not gonna go into too many details, but I will say that we have the ability to apply policy and apply zero trust not only on application access, but also on network features. So for instance, under a certain context, I will be able to receive server initiated communications or initiate a peer-to-peer connection. And under another context, I would not. So the ability to not only limit the destination, but also limit the features of the network in a way that adjusts to the context is really crucial in providing VoIP that really assumes network access while not giving the network access and maintaining this zero trust paradigm that really validates everything and checks and applies policy in accordance to context and not in accordance to network.
How the solution would work if I'm having a very slow connection that interrupts, or maybe even if I'm roaming and I'm changing from one network to another.
So part of the advantage of stopping to use network as the arbitrator of access and starting using a policy engine is that you make the rules. So it can be determined that the connection will not be disconnected. However, if, for instance, you set policies that say, okay, from this IP, you can access that server, but from the other IP, you cannot, then if you roam from a supported IP to an unsupported IP, then the continuous authorization model will cut you off mid-session. But that's not by default. That's because of a deliberate policy decision. So unless any policy rules are broken, you will be able to roam from one network to another uninterrupted. And you get to choose whether the network comes into play in your policy or maybe not.
What about user behavior or reporting? Can you tell us more what you guys can provide?
Of course. So we, as I mentioned at the beginning of this episode, we are a zero trust application access solution. And by application access, I don't only mean that we give access to the specific applications without giving access to the network. I also mean that we operate on the network level, on the application level, pardon me. Now, this means that in most cases, we are application aware. So we will be able to tell you, and maybe let me even show you this because this is a very cool part. So we can show you not only who connected to what, but also what they have been doing. And, for RDP, this can be visual session recordings. This could be all the files that were retrieved during the session, all the actions, if you shared a clipboard or USB device or anything really, it will always show. Now, many solutions will tell you Gil connected to domain controller, but we're going to actually show you what Gil did. And the same goes with connecting to web applications. I'll show you the downloads, I'll show you the uploads. You can advise with your DLP. So anything.
Is this for clientless and client?
Yes. And this, for instance, is a database session where we ran some operations. Now, this sort of visibility is unparalleled, and you're not going to find it anywhere else. Some solutions are especially for visibility for remote access, but as a zero trust access platform, none will give you this level of visibility, user level, application level, device level, and action level. Now,
so I can create a report of where Evgeny went for the last 2 days.
Correct. And I hope there's data here, but if we're gonna click me, what we're gonna find is that we're gonna get the timeline for my user. And let me just choose. So we're gonna get the timeline for this user. And it's been a little while since I used this demo tenant, so that's the hiccup. Now, all this can be consumed using our Insight dashboard, which again, you're not going to see much data here because it's a private tenant of mine, but you can really consume it from anywhere. But you can also stream the logs into your Splunk or into another SIM or UEBA solution and really have these smart decisions made on the basis of the user actions and not only on the basis of the user destinations.
Gil, we actually, yes, it does. We actually done with the official part of the show, and we're moving to kind of more of free flow. We have some questions, and you can ask questions as well. When you were showing the reporting, you mentioned about DLP. So I have like a two-part question. One, what do you do with outbound browsing or SaaS applications? Mm-hmm. Do you usually pair with a different solution? Do you provide some visibility protection blocking by yourself? Mm-hmm. And maybe you can talk more about what you mentioned about DLP because it's very interesting.
All right. I'll start with the SaaS. So many organizations are moving to SaaS, adopting it very quickly, and the advantages are huge. Our solution has something called a selective web gateway. Which is sort of like a SWIG, but only chooses the applications that are relevant for the organization. So when your employees go on Facebook, we don't want to tunnel that. You can choose to do it, but that's not the best practice. If they do go to G Suite, Office 365, Box, all of those, then our selective web gateway will be in the middle and really be able to authorize different actions, give you visibility, just like you would expect it from private applications. So, this whole SASE vision is not only about private applications, it's about access as a whole. And that's our approach here, and that's our offering around SaaS. To answer your second question is the DLP. Our solution is very unique because it sits on the crux between the users and the applications and the servers. And much of the communications go through us because we are the arbitrator of policy and the arbitrator of access. By being able to look at it and being able to look at it on the application level, which again, this is something that sets us apart from so many other solutions, we can also see the files that are being transferred. So if you're during a Git session, SSH session, RDP session, HTTP session, it doesn't matter. So across so many protocols, we can see file transfers. This is a very unique point of view to the organization. And if instead of connecting all those different things to your DLP, you can connect this one access broker to your DLP and make sure that across different protocols, every file that's being downloaded is advised with the DLP, and it's made sure that this file can be downloaded. So you get a verdict from the DLP, and if it looks safe, only then you get to download it. So you get much simplicity because you don't have to connect all the different applications to the DLP, but just this one access broker. But also you get this benefit across different protocols and different use cases. So this is a very elegant way of making sure your data doesn't leak. Now, this is just one example, but being the arbitrator of communication across the organization really puts you in a unique position to become this platform where you get more value from your SIM, more value from your UEBA, more value from your anti-malware, more value from your DLP, just because they all connect and they all connect in a centralized way. And I hope this answers the DLP question.
I don't think we have any more questions. Any questions to us?
Yes. So you have been talking to so many incredible companies and, some of our peers here in the Zero Trust space. Many are good friends of mine. And I wanted to ask, after having spoken to all of those really talented entrepreneurs and seeing their solutions, what do you think the next frontier is in terms of SASE, in terms of Zero Trust access? What would be the next holy grail that companies would be wise to pursue?
It's, as you say, it's a very good question, and that's many other vendors. So first of all, the reason I ask you about outbound browsing, because I personally feel that ZTNA and SWG firewall as a service will have to collapse in one way to another. It's the same pipe, so they have to work together. If they're not going to collapse, they have to work in integration with someone else. There's also very, very big buy-in to identity. And one of the reasons why we asked questions about reporting and UBA is because I personally feel we now providing the pipelines and the way to go to the internet. The next level will be, how do I stop people from doing stupid things? How do I understand that people doing stupid things? And we don't have the people to actually go and research and log and analyze what they're doing. So we want the system to help us to profile what Evgeny is doing, to profile what Gil is doing. And if it's Gil doing something that doesn't look like he did it yesterday or for the last week, it will alert me. So it's more UBA-ish to ZTNA and outbound browsing. Maybe not going to stop me. Maybe it will able to trigger more authentication, depending from where you're located, or the amount of files you're downloading from a SaaS solution or on-prem solution. So in my mind, this is one direction that probably will go. And the second one is probably my personal kind of projection. I think the EDR market will join the SASE market, or the Zero Trust Edge, as Forrester call it, in probably next year.
So it really aligns with the way I see things. So I'm very happy that we're aligned here. And thank you both for your answers. That's really insightful.
Thank you, Gil.
Thank you.
Please remember to subscribe to our podcast and join us for our next episode.